Here I am going to discuss about water splitting. So, why we need water splitting first of all? Here from the graph, we can see that the fossil fuel production is decreasing day by day. This fossil fuel reduction has been a topic of concern for several years, and also reducing fossil fuel and their production is an important step towards mitigating the climate change. The positive side of reducing this includes a change in climate, increased air quality, energy security, and it has other economic benefits as well. And as a result of this decrease in production, we are shifting towards renewable energy sources for a better future. There has been a significant hike in renewable energy production and consumption in recent years. Now we can take a look at what are the renewable energy sources of energy that we use nowadays. Some of the main renewable energy sources are solar energy, wind energy, hydropower, tidal energy, geothermal energy, etc. So first we can discuss about solar energy. Solar energy is energy generated from the sun's radiation. It can be harnessed using solar panels or solar thermal technologies. It will create electricity or heat. Next is the wind energy. Wind energy is generated by wind turbines. It will convert the kinetic energy of the wind to electrical power. Then comes the hydropower. Hydropower is generated by using the energy of moving water, such as from waterfalls, rivers, or ocean tides. And tidal energy is a form of renewable energy which uses the power of ocean tides. The renewable hydrogen cycle is a process that uses renewable energy sources to produce hydrogen. It can be used as a clean fuel for different varieties of applications. And this cycle consists of main three steps, that is the hydrogen production, the hydrogen storage, and hydrogen consumption. Here I am going to focus more about the production of hydrogen, that is through water splitting reaction. First we can take a look at the production. The production of hydrogen can be done through a variety of sources including natural gas, coal, biomass, and water. And the storage, hydrogen is typically stored as a compressed gas or a liquid, or it can be stored in solid form using materials like metal hydrides or carbon nanotubes. Compressed gas and liquid storage are the most common methods, with compressed gas storage is the most widely used for transportation. Hydrogen can be consumed in variety of applications including transportation, industrial process, and electricity generation. So, among other fuels, these are some of the advantages of hydrogen as a fuel. It has highest chemical energy density, it has zero carbon emission, and the abundance of water on Earth is also a pro for hydrogen as fuel, and the combustion product is water in electrolysis. These are some of the different methods of water splitting. The first one is electrocatalytic water splitting, which I am going to discuss. The second one is photocatalytic water splitting, which uses the energy from the sun to split water into hydrogen and oxygen. The third one is the most common one, which is used in industries for producing hydrogen, that is the steam reforming. But one of the main disadvantages of this process is that it has many byproducts like carbon dioxide, carbon monoxide, which is very harmful for our health. Among these three techniques, the advantages of electrolysis of water is that it does not require high temperature and pressure as we see in the industrial production, and it does not release any hazardous materials, and the source and combustion product are water itself in the case of water splitting. Here, the purity of hydrogen formed is very high, and also no greenhouse gas emission is produced. Among that, the electricity generated from renewable energy can be used as the electricity generated from the renewable energy can be used as the input energy. So now we can take a look at the basics of water electrolysis. It can be done in either acidic medium or alkaline medium. So here this is a picture of alkaline electrolysis. In alkaline electrolysis, usually the electrolyte is potassium hydroxide or sodium hydroxide. These are taken in a beaker where two electrodes are immersed, which is a cathode and anode. At cathode, the hydrogen is produced, and at anode, the oxygen is released. At anode, due to the splitting of water, the OH minus ions travel towards the positive anode electrode, where it generates the oxygen as a gas and hydrogen water as water molecule with the production of 2 electrons. This 2 electron will go to the cathode, and through the flow of this electron we can see that an electricity is produced along with the production of oxygen bubbles. So by calculating the amount of current that is generated, we can assume how much amount of oxygen is produced at anode and at cathode vice versa. At anode, 2 OH minus ion becomes H2O plus half O2 plus 2 electron, but actually this is a four-step process, but this is simplified in single step. And at cathode, this 2 electron from the anode combines with the 2 water molecule to form hydrogen gas and 2 OH minus ions. So in conclusion, the overall cell reaction is H2O becomes H2 plus half O2, that is 2 moles of water molecule will give 1 mole of hydrogen gas and 2 moles of hydrogen gas and 1 mole of oxygen gas. So in order to take a closer look at what happens at the electrode, we need to understand the kinetics of water oxidation and reduction. So the kinetics at electrode is explained through three basic models, that is Helmholtz model, Goi-Chapman model and Stern model, which is a combination of Helmholtz model and Goi-Chapman model. First we need to consider the tipped electrode, that is a metal which is immersed in the electrolyte, and consider the oppositely charged ions that comes and get adsorbed on the surface of this metal. So according to Helmholtz model, it will create an inner Helmholtz plane that is a series of these ions on the surface of the electrode. Helmholtz model is usually used in high concentrated solution, but in Goi-Chapman model, a diffused layer is followed after the electrode surface. But in Stern model, after this inner Helmholtz and outer Helmholtz plane, comes this diffuse layer of ionic particles. Sometimes when the oppositely charged ions try to come and absorb on the surface of the metal, it will be covered with water molecules. That is called the solvated cation, and it will block other ions from sticking the electrode. It is shown in the figure, and these all will account to the resistance offered by the electrolyte in adsorbing these ions on the surface of the metal. Some mathematical explanations behind this rate of charge transfer is given. When this oxide species combines with the one electron to give the reduced species, the rate of forward reaction and the rate of backward reaction is given. That is, the current at cathode by NFA. F is a Faraday constant, A is area, and N is the number of moles participated, where CO is the concentration of the oxidized species and Cr is the concentration of reduced species. K is the rate transfer constant. So the net reaction will be rate of forward reaction subtracted from rate of forward reaction minus rate of backward reaction. That is I by NFA. And by incorporating the activation energies followed by further simplification, this rate constant at other potentials are expressed as follows. And it is a very big derivation, and in the end of this, through simplification, we will get the current that I equals F times A K0 into e raised to minus alpha F e minus E0 CO minus e raised to 1 minus alpha F into e minus E0 Cr, where alpha is the activation energy. This equation is known as Butler-Formel equation, and it is a very important factor in studying water splitting reactions. Now we can take a brief look at the electrode setup which we use in water splitting reaction. That is, we can use 2 electrode system or 3 electrode system, but for more accuracy and getting more detailed value, we use a 3 electrode setups. It has basically 3 connections, that is a working electrode, a reference electrode, and a counter electrode. A working electrode is where we apply the catalyst which we will take for studies, and the reference electrode is an electrode which shows no deflections or change in the voltage when current is passed through. We will use HgHO mercurous oxide electrode or silver chloride electrode or standard hydrogen electrode or etc. If you are using mercurous oxide electrode or anything else, we will change the values to standard hydrogen electrode or normal hydrogen electrode values. The other one, which is the counter electrode, it is placed far away from both this working electrode and reference electrode so that it will not take part in any of the reactions. And the setup is closed with a Teflon cap, and sometimes we will purge this electrolyte using nitrogen gas. This overall setup will be connected to a potentiostat to apply the voltages across the working electrode and the counter electrode, and we will obtain the measurements accordingly so that we can analyze the water splitting reactions on overall. And from the potentiostat, which is connected to a personal computer, by using different softwares like AC Lab, we can obtain the result of the of this electrochemical processes. We will use electrochemical techniques like cyclic voltammetry, linear sweep voltammetry, electron impedance spectroscopy, chronoamperometry, etc. for analyzing various properties of our reaction. Thank you.